All right. As if we didn't already have enough different variables that have to do with the letter P, we're going to throw in one more in here into this third step of our hypothesis testing. And we're going to use something that we're going to refer to as the p-value for measuring surprise. So the null hypothesis tells us what to expect when we look at our data. If we see something unexpected, that is when we are surprised, then we should doubt the whole null hypothesis. If we are really surprised, then we should reject it altogether. So the p-value is a probability, which is why we use the letter P, right? Because it's a probability. It gives us a way to numerically measure our surprise. If the null hypothesis is true, the p-value is the probability that the experiment was repeated. Our test statistic will have a value as extreme or more extreme than the value we actually observed. Small p-values close to 0 mean we are really surprised. Large p-values close to 1 or 100% mean we are not really surprised at all. Alright, so we first need to figure out what the phrase means. If the null hypothesis is true, the p-value is a probability that if the experiment was repeated, our test statistic will have a value as extreme or more extreme than what we actually observed. So what we're going to do is we're going to break this into our two-sided and one-sided cases. So if the alternative hypothesis is P does not equal P naught, it's a two-sided test. Looking at this, notice that we have two little tails in our picture, right? Then as extreme or more extreme means even further away from 0 than the value that we observed, right? This corresponds to finding the probability in both tails. So that's why we called it a two-sided, because if we're thinking about this p-value further away from 0 than what we observed, it's going to land in one of these two tails. Right, now, if we compare that to our other types of alternative hypotheses, our other ones are one-tailed, right? So we've got an example of a left-tailed p-value and a right-tailed p-value, right? So what we're thinking about and what we're deciding on here is this a value that's extreme enough that it lands in one of those tails? And that's going to go through and that's going to help us make our decision as we're going through and we're working on this hypothesis testing procedure.